Okay, I'm going to go through a couple of branch circuit calculations. The first one, it's going to be out of your example or your objective exercise in your module. So I'm going to do number 3, the electric water heater, and I'll do number 4, the electric space heater, just to kind of clear up. I think the range and dry are pretty straightforward, but if you want me to do a video on that, just let me know. Email me and I can do one for that too. Okay, so the reason I want to pick this guy because he's a continuous load, so they're a little bit different than other straight loads. Basically what they've determined is that it's going to be on for a long period of time. So I think rule 81043 says on for more than an hour in a 2-hour period or more than 3 hours in a 6-hour period, then we're going to consider it to be continuous. Just means that it's going to be on longer than it's off. Okay, so the first thing we do is we still have to find the actual current draw so we can size a wire for it. So we're going to take our 4,000 watts, divide by 240 volts, and we will get our current of 16.667 amps. Now, because it's continuous and it doesn't say what the breaker rating is, we're going to say it's at 80%. That's the default. Okay, and that's in the appendix. I can show you guys where that is if you like, but just know that if it's not stated, that is the default. So we take our 16.667 amps and we divide that by 0.8 or our 80%, and we get 20.83 amps. So it's not that the heater's going to draw this, it's still only going to draw 16.67 amps. It's just going to draw it more often so it could create more heat. So we might potentially want to upsize our wire because of that. So that's where this is coming in. Now we're going to use this value to go to table 2 and find our conductor. So if we go to table 2, it's going to tell us to use a number 12, which is good for 25 amps. Okay, and that's under the 75-degree column because that's what the question said in their module. Okay, so that's good for 25 amps. So normally what we do is go to table 13, and we would choose a breaker based on the wire size. Again, our breaker is going to protect our wires, so we use this ampacity to choose the breaker, not this one. Okay, so I'd go to table 13 and choose 25 amps. Now, there is a thing with the certain wires on table 2 that show, there's a little indicator that shows that there's something else to look at. So if we look here on table 2, these little double S notations here basically are referring us to rule 14104. Okay, so I'll just show you on the back of that. So right here, it's saying for that, see rule 14104 sub rule 2. Now that rule is going to tell us that we have certain maximums for our breakers. It's going to say we can only have a number 14 can only be on a 15 amp breaker, number 12 can be on a 20 amp, and number 10 can be on a 30 amp. So this is from 14104.2. Okay, so this comes into play because we're just in the general section of the code. This rule does not apply to the specific sections, which would be heating, section 62, motor, section 28. Okay, these are basically for just the general section, which we are in right now doing branch circuit calculation, section 8. So I can't put this number 12 on a 25 amp breaker is what this is saying, because it's saying I can only put it on a 20. Now I can't drop this down to a 20 because I need to be able to cover my load, and because it's continuous, this is the amperage I'm looking at. Okay, so I can't put it on a 20 amp breaker, obviously, because it's too small for this value here. So I'm going to have to go up instead to a 30. Okay, so if I go to a 30 amp breaker, okay, now that's going to dictate what size of wire. Okay, I still can't pull number 12s and put them on a 30 amp. From 14104, it's telling me right here I got to use a number 10. Okay, so for this question, I'd be pulling number 10s and putting them on a 30 amp breaker. Okay, so that's how 14104 can come into play. And it can change the answer even though you've done this part 100% correct by going to table 2, sizing it from your load, then going to table 13, sizing it for your wire. we do have to make sure and check if we're in the general sections that 14104 does apply. Okay, so now let's look at number 4, because it's a similar wattage, but it's a different type of load, so it's a good example. So we have a 4 kilowatt space heat scenario now. So again, if we look at section 62, because we're going specifically for space heat, so we go to section 62, and don't get this confused with forced air gas-fired furnaces, okay, that we're doing in lab. Space heat is just electric space heat. So like baseboard heaters, you can have electric heat in a duct system too, I would imagine, but it has to be electric space heat, not gas-fired furnaces, okay, so don't get those two mixed up. So for space heat, go to section 62, it says that rule 62.110 is saying it can't be less than the connected load. So we take our 4,000 watts, again, divide that by 240 volts, and get our connected load draw of 66.667 amps. So we would take this now, and it's not a continuous load, so we're not going to do this the same that we did up here. We're not going to do that this time, okay, because this is a heating load. So we're going to go to table 2 now, and we can see that a number 14 is good for 20 amps from table 2. Okay, so that's from table 2 under the 75-degree column again, because that's what the question stated. So we find that we can use number 14, which is good for 20 amps. Now when we size our breaker, there's another rule for heating and cooling that we have to make sure and check. Rule 62, 114, 6 and 8. So number 6 says the load cannot be greater than 80% of the overcurrent rating. So here's my load. So this is my load here. This is my overcurrent. So is this value, it can't be greater than 80% of the overcurrent. So let's see, well, let's take this 16.667 amps. We'll divide that by 0.8, again for a different reason, not because it's continuous, but because we're checking to see if it's 80% of this breaker. Same value though, we're going to get 20.83 amps. Now that shows me that it is greater than 80%, okay, because 20.83 is larger than 20. So that tells me that my load is greater than 80% of this, which I can't have. So then I go to table 13 and see, well, what's the next available breaker size? So table 13 is going to tell me that that's a 25 amp breaker. Okay, so now I'm going to add the scenario where I'm going to take a number 14 and I'm going to put it on a 25 amp breaker. Okay, so now we've made sure that we followed rule 62, 114, 6. Number 7 now says that we can't be smaller. Okay, sorry, that the amperage of the wire can be smaller than the breaker. So it is in this case, because the amperage is 20 amps and the breaker is 25 amps, as long as the ampacity is at least 80% of the overcurrent rating. So the ampacity of the wire, so that's the 20 amps. So we want to see is this 20 amps at least 80% of the overcurrent. So if we want to check that out, we can just say 25 amp breaker times 0.8 and we would get 20 amps. So it is at least 80%. Okay, so this 20 amp wire is okay to put on that 25 amp breaker, and that's rule 62, 114, 7. So just a couple of checks that we have to make sure before we say this is good. So because this wire is 20 amps is at least 80% of the overcurrent rating, which is the 25, we're okay to use it. So this is our answer right here. So we can use number 14s, put them on a 25 amp breaker. Again, we had to bump it up here because this load had to be couldn't be any larger than 80%, so we had to bump that up. And the reason for that, I would say, is that even though heating, electric space heating could have temperature, it could cycle on and off, it could be on for a long time, so there could be a significant draw. So we just don't want to load that breaker real tight on the amperage for the wire. So in the two examples, same wattage, different type of load. We're pulling number 10s on a 30 in this example, and we're pulling number 14s on a 25. Okay, just because this was a continuous load and this was a space heat load. Okay, so make sure you get those figured in there, and you're definitely gonna have to connect loads like that in the field, so it's good to have an understanding. So let me know if you have questions about those, and the answers are in your book as well too, but that's how you figure it out.